Hello, this is Ben McGahee with McGahee Mathematics, and in today's video we're going to look at Introduction to Polynomials. Poly, the prefix, means many, and nomials is names or terms. So you're looking at polynomials or many names or many terms. But a mathematical an accurate definition of polynomials is a sum or difference of monomials. So let's talk about what a monomial is. So a monomial is a polynomial with only one term. So you're just talking about one term. So an example of a monomial would be 2x. 2x. Just one term. Second type of polynomial we'll look at is a binomial. So binomial, the prefix with bi means two, so we'll have two terms. So an example of a binomial would be something like y plus 3. So y is a term, and 3 is also a term. So those are two monomials added together. Third type polynomial, it's called a trinomial. So you probably guessed that trinomial, tri means 3, so you have 3 terms. So an example of a trinomial would be something like a squared minus 4a plus 6. A squared is a term, negative 4a is another term, and 6 is also a term. So you have 3 terms for a trinomial. And now we're going to look at a couple of things as far as, let's say, degree and coefficient. These are a couple important terms that we need to look at. When describing polynomials. So degree, coefficient. Degree of a term is basically the sum of all the exponents. So you want to, add all the exponents together. So sum of exponents. So, for example, if we were looking at the 2x term, this monomial here, just one term, we look at the sum of the exponents. So x is just x to the first power. So that's the only exponent we see. And so our degree for this term 2x would be 1. So I'll just write d next to it for degree 1. If we were looking at, let's say, the degree of the y term, this would also be the same thing because it's just y to the first power, so there's only 1, so that degree is 1. And then the same for the a squared, except this time we have a different exponent, which is 2, so the degree is 2. But what about constant terms? Like we have 3 here and 6 there. What are the degrees of constant terms? or constant values? Well, the degree of a constant term is always 0, and let's see why. So if we have 3, we could say that 3 is equal to 3. We'll just use x as a variable, x to the 0 power. And x to the 0 power equals 1 for any x that's not equal to 0. So positive, negative values of x to 0 power is 1 as long as x is not equal to 0. So 3 times x is 0 is 1. 3 times 1 is 3. So we can reason that that's why the degree of a constant term is always 0. So, and it makes sense because there's no variable, so there's 0 degree. Okay, what about if we have something a little bit different? Let's say we have 2 variables, different exponents. Because notice that we have sum of exponents, so we need to add them together. So if we have like 5m squared n to the, let's say, 7th, then we have 2 variables. We have m and n, so we need to take the exponents of the m and the n and add those together. So we're going to sum them together. So 2 plus 7, that equals 9. So we have a degree of 9 for this polynomial. Okay, so if you just have one single variable term you're looking at, you just look at the exponent. But if you have more than one variable, you have to add them up all together, all the exponents, to get the degree. Okay, now we're going to look at coefficient. So coefficient is basically the number is a b multiplied by the variable. So I'm doing the best I can with writing here. I'm using, of course, a mouse. I had a little practice writing with the mouse since I work tutor online. But if you have trouble reading anything, understanding something, just feel free to, send me a message, email, or comment on Facebook, and that way I can make these videos a lot better so everyone understands. We're all on the same page. So just a side note. So coefficient is a number multiplied by a variable. And so if we look at the first term, 2x, we can see that the coefficient here is the number for 2. So we'll just write C for coefficient, 2. The term for y is kind of tricky, but we know that y is equal to 1 times y, right? Because any number times 1 is itself. So we know now that the coefficient of just y, or 1y, is just 1. And then likewise, if you have a term, let's say negative z, this is the same thing as negative 1 times z. So the coefficient of negative z would be negative 1. So if just a variable and there's no number, it's just going to be 1. If you have a negative in front of the variable, it's going to be negative 1. The coefficient for 3, we notice that the degree of the constant term is 0, but the coefficient of 3 is just 3. So it's the number you see there. And the same thing for 6 too. Coefficient of 6 is just going to be 6. What about the coefficient of negative 4a? Well, the number in front of negative 4a is a negative 4. So we know the coefficient of negative 4a, this term, is negative 4. And then for a squared, it's just a 1, right? Because there's no number in front. Coefficient of 1. And coefficient of 0 would just be 0, you know. And it also has degree 0. It's the only term that has both degree and coefficient of 0. Called the zero polynomial. So, okay, so we've talked about the degree and the coefficient of individual terms, and now we need to look at the degree and something called leading coefficient of an entire polynomial when we have two or more terms added or subtracted together. So let's create a new board here. And okay, so we're going to have degree and leading coefficient. Okay. Degree and leading coefficient. So let's say we have, some terms here with a polynomial. You have, let's say you have 8x cubed minus 5x squared plus 2x minus 4. There's a 2x minus 4. So to find the degree of this polynomial, we notice that there are four terms, right? 8x cubed, negative 5x squared, 2x, and minus 4. So the degree would be the largest exponent that we see in this polynomial. So we start looking at the exponents. We have 3, 2, this is 1, and the degree of a constant term is 0, right? So we take the largest exponent, which is 3, and this would be our degree for the polynomial. So this is the degree 3 polynomial. So that takes care of the degree part. The leading coefficient part of the polynomial is the number that belongs to the leading term. So the leading term is 8x cubed. It's got the largest degree. The leading coefficient would be 8. So that's LC for leading coefficient is 8. Okay. So there's an important thing you need to know when you're doing polynomials, and there's a certain order in which mathematicians like to write polynomials. And they do this for a certain reason. It's called descending order. So if you think of descending, like a plane is descending from high altitude in the sky to the ground at the airport, so it's going from a high altitude to a low altitude, or the lowest it can go, which is on the ground. So the same is true, applies here with polynomials. So let's say, for example, you have 10x to the fourth plus x squared minus 7 plus 12x to the 6 minus 18. So the descending order, you usually want your terms to go from, the highest degree to the lowest degree. Okay, so we look at our exponents. We have 4, we got 2. This degree would be 0, right? It's constant. And then we have 12x to the 6, negative 18, 0. Let's change this to an x, minus 18x, because negative 7 and negative 18, you could add those together, and of course we're going to be doing that in our next video. We're adding and subtracting polynomials. So we look at these, 4, 2, 0, 6, and then this one would be 1, right? Because we had an x there, minus 18x. So we take the highest degree term, that's going to be 12x to the 6. So we're taking care of that one. And then we go to the next highest, that's going to be plus 10x to the 4th. Done with that one. And then we look at plus x squared. Done with that one. And then we have x to the first power, that's minus 18x. Done with that one, that leaves us with minus 7 at the very end. So we've gone in descending order, highest degree term to lowest degree term. And this makes it a little more readable. We can now determine the degree, because now the degree of the polynomial is the highest degree term, and we notice we see that first, right? 12x to the 6 is the highest degree term, and now we have a degree 6 polynomial. So our degree is 6. And the leading coefficient belongs to the highest degree term, which is first. Very convenient, right? So the leading coefficient is 12. So that's why mathematicians like to write polynomials in descending order, so that way they know that the first term has the degree of the polynomial and it has the leading coefficient. So this is it for polynomials here. Introduction, polynomials. So this has been McGahee with McGahee Mathematics. Thank you for watching this video, and do stay tuned for adding and subtracting polynomials.